Software-defined networking for man is what we call as SDWAN, and it's an overlay concept
Mm.
where we are going to have a virtual tunnel, which is an overlay tunnel, regardless of what type of underlay we have. We may have multiple paths like IP network or MPLS network or leased line. That doesn't matter for those who use the overlay. Overlay never cares about the underlay. Overlay simply provides uh, a tunnel, a control plane, which is focusing only on the routes that are provided by the edge routers, means the sites.
Mm.
The overlay no need to worry about uh, what underlays. Usually, we used to bind things to the underlay. Here, we don't bind to any underlay. Underlay will be used by this application as the WAN application, and then it will abstract and provide us only the overlay for us to use. So you need to focus only on the overlay
Cool.
using which you can have your own path. As per the policy, you will have your own path.
Got it.
We use a lot of things like color, site ID, system ID. I do not want to get into those technical stuff now, but what I'm saying is only those things we will be focusing. We are not going to focus on the underlays. We simply say encapsulation or color MPLS, color WAN interface, something like that. So those things are all actually policies which is going to work behind the screen to provide you the path using the physical underlay. So SD-WAN is isolating the physical WAN and physical server. It is going to provide you a virtual WAN overlay, which we will use to have a policy-based routing. But before getting into those SD-WAN thing, we need to just focus on what we were having before, so that we can understand what SD-WAN is.
Correct.
From where the SD-WAN has come. Long back, you are not new to data centers, so I can speak this. Many years back, maybe like 12 years back, Cisco was not this bright when it comes to data center.
Correct.
Only MDS switches were there, and that was somehow providing a better SAN experience.
Correct.
Later, 1000V Nexus,
Correct.
along with VMware company,
Correct.
was born. So VMware were also not that big like now. VMware was also very small, not much big like this. Today it is big. So both the companies gained by sharing their ideas.
Correct.
The problem with VMware was they were not able to connect to the physical network.
Correct.
VMware where VMware LAN segments were not extended to the physical LAN segment. For example, VLAN 10 of VMware, virtual VDS, virtual distribution switch,
Correct.
and the VLAN 10 of the physical box outside was not in same broadcast domain. They were not combined, they were separate. VMware was isolated from the physical world. To provide visibility to the VM switches, virtual switches, Nexus 1000V was very useful.
Correct.
So VMware started growing because the visibility down to the virtual world is now available through this Nexus.
Correct.
Later, VMware developed their own protocol to provide visibility to the physical world. So now no more 1000V and VMware connected.
Correct.
But a lot of virtualization idea was copied by Cisco from VMware people. So they developed Nexus devices, modular Nexus devices. Like VMware were having modular approach for management VLAN, for management a separate VLAN, for control plane separate VLAN, and there was one vCenter, and then vSphere clients. So that relationship, those ideas, helped Cisco to come up with supervisor modules and IO modules. So the control plane in VMware was vCenter, and all the vSphere client were like a data plane, like line cards.
Correct.
There used to be a term EOM, Ethernet over module, something like that. So the idea was copied, and then Cisco came up with a box like Nexus 7000, MDS 9000 series with redundant supervisor module,
Correct.
and then line cards. And to combine all this thing, this is the front side of the box. At the back side, to combine all this fabric,
Yeah. Fab cards were there. 2 fab cards.
many, more faster you want, more fabric card you can install. So that there will be more fast communication between the line cards. So, so the switch fabrics, this idea was taken from the VMware world. So they came up with this modular approach. These two boxes are like redundant vCenter, VMware vCenter. That's the idea from where. And these are all like vSphere clients, separate, virtual switches. So this all can be combined as distributed virtual switch. Somehow they managed to do this. That's how we got Nexus 7000 series, ASR 9000 series, and so on. Now, again, they broke this into pieces. They call it as EPIC. This EPIC is a orchestrator. So more software defined features were added and it was kept separately. And as EPIC is connected to leaf and spine. Now through EPIC we put the necessary configuration as the EPGs are added, as the end devices are added to the leaves. Leaf is the intelligent device here. Spines act as a route reflector, as a backbone, as a fabric card. See, this is like a line card, like a fabric card. More spine you have, more faster your ACI is going to be. And this is like a line card. And this is like supervisor module. So same Nexus switch you see here, it's scattered in pieces. This is, you can imagine, right? The supervisor
Correct.
module.
Yeah,
These are
yeah.
all line card of Nexus 7000.
Correct.
This is the switch fabric,
Correct.
FC card.
Yeah, it's the same thing.
Same thing.
Yeah.
And this we call it as ACI.
Yeah.
Only thing is the advantage here is you got application policy, infrastructure controller EPIC, which controls this. You define the policy, you define everything here accordingly. The configuration, necessary configurations are pushed to the appropriate leaves. A lot of other things I do not want to go in, like 1000 ARF and all. This is not ACA class.
Correct. Correct.
So,
Yeah, they came up with the Nexus 9000
yeah.
in ACI mode.
Now, the same idea is what you will see here in SDWAN. Nothing new here. Same what you saw in ACI, same what you saw in Nexus 7000. You got switch fabric. Which one is the switch fabric in SD-WAN? Internet is the switch fabric. Service provider, the WAN, the cloud. The WAN that you connect, the WAN connection, the MPLS, the underlay, the WAN connection, the internet connection, they are like a switch fabric for us.
Correct.
They are like spine in ACI. All the edge devices are IO modules.
Correct.
And then all those three controllers in SD-WAN are providing you the control plane. The three controllers are vManage, vSmart, vBond. If you see in Nexus 7000, the supervisor module never comes in between line card when the traffic flows.
Correct.
They stay away. They just provide the path information to the line cards. They provide all those forwarding plane informations, and then they are staying apart from the traffic flow. They don't go in line. They don't sit in between.
Correct.
Same way, if you see in ACI, EPIC is the reason for all policies and configurations on leaf But Epic never goes in between the traffic flow. They stay away.
Correct.
Likewise, this vManage, vSmart, and vBond, they provide you this control plane between the edge device. They provide the path to be taken between the edge devices, between the sites, and they also define whether the path needs to use only GRE or IPsec. All those things are defined using vManage, and using vSmart, it has been advertised to all the VHS, and using vBond, all the VHs are identified and reported to vManage and vSmart. Means the inventory of SDWAN topology is done by vBond. Like when you insert a line card in Nexus 7000 series, that line card comes online on the supervisor module. Yes or no?
Correct.
When you insert a line card, supervisor module knows that a line card has come up, a new line card has come up,
Yeah.
slot number 8
Correct.
is up online.
And we use
Likewise,
this soup to connect, and then we can issue a CLI to see whether that is up.
yes, likewise. When new edge device, it may be C edge or V edge, whatever we call it as WAN edge now. When a WAN edge comes, vBond knows using certificate or through some mean of checking the credential. It does the check using the information that was earlier shared by vManage to vBond, and vBond now provides the location of vManage and vSmart, using which the vEdge becomes part of SD-WAN. So what I'm coming to show here is SD-WAN is not something new. SD-WAN is another modification done to the existing modular approach. So here also you have a control plane module, which is no way participating in which is not coming in between the traffic flow, like a supervisor module. This also stay away from the traffic flow.
Correct.
We got a internet which is going to provide us the switch fabric, like a spine in the ACI.
Correct.
For us, the spine here is the WAN itself. The leaves or edge device. So if you know how this Nexus 7000 or ASR 9000 works, it is very easy to understand how SD-WAN works.
Yeah. I worked in MTS. I was in the same team for around 6 years. So all series of MDS which were released, right, from 9250 to all line cards, 9706 or 9710. So I worked on all those things. So I was part of that same QA team.
Okay, then I'll
Yeah,
speak in MDS language now.
yeah,
So now what happens when a server is connected? The floggy happens.
correct,
The fabric login happens, no?
correct,
So the WWPN address and WWNN address
correct,
are learned on the F port,
correct,
and that is learned on a line card, but supervisor module will know about it. Not only that, all other line cards will also know the location of this WWPN and NN, which is in different line cards. So there is a
Correct.
control plane which helps to distribute this information of new server that is added to module 8. You attach a server to module 8. Immediately the WWN addresses of this device
Correct.
is available in
FCNS database.
loggy and FCNS
Yeah.
table.
Correct.
It is the same job what the vSmart does here.
Mm-hmm. Got it.
When a LAN is advertised by an edge device, when LAN networks are advertised by edge device, maybe using OSPF or BGP, this vSmart learns it through OMP, and this vSmart distributes this information to all other VHs so that the other LAN on the other VH can reach this LAN on this VH.
Mm-hmm.
And the path selection will be as per the policy that we have configured using templates in pmanage. So in short, what I want to say here is SD-WAN is not something new. It is the same story which began like 12, 13 years before in Nexus 1000V.
Correct.
If you see 1000V and understand 1000V, you'll understand Nexus, you'll understand MDS.
Correct.
When you understand these things, you'll understand ACI. When you understand ACI, you'll very well understand SD-WAN.
Correct.
Because the ACI's EPIC is what we manage vSmart and vBond. ACI's EPIC is what we manage vSmart and vBond. And ACI's spine is what WAN, or WAN is what spine.
Correct.
Leaf is what the WAN edges. So, like ACI, this is also a software-defined ACI we call application-centric infrastructure. Here also it's the same application, that's why it is SDN. Right, so that is what this picture explains here.
Mm-hmm.
This is physical box Nexus, which has got supervisor module, line cards. Sorry. There's a fabric. Usually fabrics are seen at the back behind this door.
Correct.
And the power supply and the fan. So this is one single box. They have put everything in one box. SD-WAN, we have separate box. Now,
But one question, see, when you think about this ACA, so this EPIC is a single controller. But here I see three different controllers. Was that a need
no.
or they could have squeezed in with one
No,
controller?
I'll tell you. In Epic also we have this three,
Okay. Uh-huh.
but they're not shown as three. That's all. These are
Oh,
three
okay.
different functions.
Mm-hmm.
See, when an Epic is connected to a leaf,
Okay.
Epic can see a device attached. Epic shows you, and then we provide a ID
Mm-hmm.
for that device which is appearing on the Epic.
Okay.
Uh, I think you have not worked on Epic.
No, I have not worked
That
on.
is why you got this question.
Yeah. Yeah.
Same like, okay, let us not get into SD-WAN, but because you have already heard about SD-WAN, when I speak about EPIC, you will map it easily. You
Yeah.
see, EPIC will be always attached to some leaves, not all leaves, one or two leaves.
Okay.
And leaves are all connected to
Spine.
spine.
Correct.
No leaf to leaf connection.
Correct.
That is what? Cross architecture.
Correct.
So now, when you connect EPIC to leaf, the switch that is connected to EPIC will be appearing on EPIC, for which you will provide some ID like 101, 102, something like that. You will give a number
Okay.
to
Got it.
identify that box.
Any new edge. Okay.
This idea, from where they brought it, they came from that Nexus 2000. Have you worked with Nexus 2000?
No.
Okay.
I have worked on Nexus 5000.
Okay. Nexus 5000, when it is attached to the child device 2000, it will show that there is a device attached on this particular port on 5000. So what we do is, we give a number called fabric ID. No, not fabric ID. We give a number called
Fabric extender, FX.
FX only I'm talking about. FX ID.
Okay. I know that. Yeah.
We give
Okay.
an ID called FX ID like 101.
Yeah. Yeah. Correct.
As soon as you
Correct.
give, you will see that switch coming up online. Show
Correct.
FX, if you type, it will show you this 2000 is online now.
Correct.
Exactly the same thing. When Epic is connected to a leaf, that leaf appears on Epic, and you give number 101 or 102, some number to identify the leaf, and that leaf will be assigned with a VTAP address dynamically from the reserved pool. Now, the leaf is discovered. From that leaf, the next spine will be discovered.
Okay.
From that spine, all the leaves that are connected to that spine, every leaf will be connected to all spines. So
Correct.
from that spine, all the leaf will be discovered by Epic. So Epic is discovering, right?
Correct.
V bond is discovering.
Okay. So there, the discovery is through the CDP, huh?
LLDP.
LLDP. Okay.
So Epic is equal to V bond. Now let me explain you how Epic is equal to vManage and vSmart.
Okay.
Epic discovers the leaf and spine,
Correct.
to which you are going to bind the policies.
Okay.
Policies you define using Epic only,
Correct.
whereas there it is a separate module called vManage. Here everything in one,
Correct.
and we create a profile, interface profile, switch profile. We have policies, and all these are combined and applied to the EPGs. EPGs are endpoint group that identifies the edge devices to which different policies can be assigned using contracts and filters. That is what vSmart does. vSmart provides a smart control plane for the overlay, which is what exactly we see between those devices that are connected to the WAN edges, the networks, the LAN networks of WAN edges. Right. Sorry.